Okay, so we can continue the lesson here. So we learned about quadratic functions. We learned that the graph of these quadratic functions is a geometrical shape called a parabola. And we learned that if I have a second degree polynomial or a quadratic polynomial of this form, the sign, positive or negativeness of this number is important. If it turns out to be positive, it will open up. Yes, if this is positive, and this point is a turning point, or in this case, it is better to call it a minimum point. So this means that my function has a minimum value. It cannot go lower than this, but there is no upper bound for my function. It can go indefinitely up. And if the number a is negative, we realize that this can happen in the graph would be of this form. Then this is also again a turning point, but in this case it's a maximum. The turning point is of type of a maximum. Okay, another name for these points are extreme points. Here I have a highest point, but there is no lowest point. There is no lower bound to the values of the function. They can go indefinitely low and low. Okay. Okay, so I don't know how much do you remember. Let me refresh your memory by starting one example to understand. I want to find the coordinates of this turning point for a given function. Let me start with negative ones, which are a little bit more tricky. So let me give an example of this, refresh your memory, and then finalize what we have learned so far. We can do it algebraically to find the formula for this turning point, okay? So here, let me give you this example. I give you a function. Let me write y instead of f of x. I write y equals to minus 3x squared plus 5x negative 2. Well, I just randomly wrote something. Of course, it might be quite a little bit complicated, not quite, a little bit complicated because of the fractions involved, but I think if you have your calculator and you are good in calculating with fractions, that shouldn't be any problem. Okay, the first thing, if you remember, I want to get rid of this negative 3. The method that we learned last time, which was good, I would say that let me get rid of this minus 3. So I divide both sides by minus 3, yes? So, by the way, I forgot to write. My point is to find the maximum of y. Because if I ask you what is the minimum of y, you immediately say that does not exist. Because you know that this is one of those cases in which a is negative, so it is going indefinitely down, so this will continue going forever, so there is no minimum level for that graph, but there is a maximum level. I want to find the maximum. So I divide both sides by negative 3, and then this becomes positive x squared, this becomes negative 5 over 3x, this becomes positive 2/3, yes? Then, if you remember at this point, you need to make a complete square out of it. And then you go to scratch paper, for example. You take this middle number, 5 over 3, minus 5 over 3, and you divide it by 2. So this becomes minus 5 over 6, yes? Because I give a denominator 1 to it. I multiply, these are far away from each other, put them in the numerator, and then multiply them and put them in the denominator. And then you remember that you have to square this, minus 5 over 6 is squared, which becomes 2536 positive. So this is the number that you need to turn the first two terms into a complete square. So you add that, but you cannot just bring it out of your pocket and put it there unless you compensate for this. And because these numbers are fractions, to compensate for that, you see, if I want to keep this equality, I have to respect the meaning of equality. If I just write it like this, it is not equality because I have an extra term which was not there, unless I compensate for this addition by subtracting the same amount. And then this is exactly what is before. But what is the benefit of that? The benefit of that would be I can write minus 1 y over 3. This term, and that term can be collected into a complete square by writing it in this form. I take the square root of this is x, take the square root of that is 5 over 6. And this is the negative version of that, so I put a negative sign there. And then this is left for me. I go to a scratch paper or use the calculator to calculate this. So it is minus 25 over 36 plus 2/3, but I need to take the common denominator. So 2/3, I multiply it by 12, the denominator becomes 36, and the numerator 24. Yes? And then I add them, it becomes negative 136, because the denominators are the same, minus 25 plus 24 is minus 1. So instead of writing it in this form, I can write it more in a more compact and nice way by writing it minus 1 over 36. Now, I ask you, what is happening for this? You see that you have a complete square. This complete square is definitely non-negative. So this means that this is non-negative. It's greater than or equal to 0. So I am adding a non-negative number to another number. So it means that the result is definitely greater than or equal to this number in its own. Yes? So what does it mean? It means that hopefully you understand if I write this. We practiced a lot on this before. I just want to write this is greater than minus 1 over 36. Hopefully it is very clear because this one is non-negative. I am adding a non-negative number to another number. So definitely the result, the outcome is greater than that number in its own. Okay, then what does this mean? This means that y divided by minus 3, which is equal to this itself is greater than that. So it means that y divided by minus 3 is greater than or equal to minus 1 over 36. I don't want to talk about minimum or maximum of this value. I want to talk about maximum of the y value. So it means that I have to make a y alone on this side. And this is easy. I have to get rid of this negative sign in the denominator. So I have to multiply both sides by negative 3. If I multiply this by negative 3, it becomes y alone. If I multiply this by negative 3 times negative 1 over 36, first of all, negative, it becomes positive. And then 3 and 36 are cancelled. It becomes 1 over 12. So this becomes 1 over 12. But the crucial point that we learned, actually we learned it in Math 1C, but I reminded you last time that if you multiply both sides of an inequality, or you divide both sides of an inequality by a negative number, you have to remember that we have to switch the sign. The direction of the sign will be the direction of the sign has to be flipped. So this becomes y less than or equal to 1 over 12. Okay, and then the answer to this question mark is clear because you are telling me that y is less than 1 over 12 or at most equal to 1 over 12. So this means that the maximum value of y is equal to 1 over 12. Now I can ask you questions. I can ask when this maximum is achieved or attained. You come back to here and say that, okay, if this is going to be equality, it means that this has to be equality. If this is going to be equality, this has to be equality. This equality happens if it takes its minimum value. So this means that this happens if this square, this expression in this pair of brackets should be 0. So this is achieved if x is equal to 5/6. So this means that the turning point or the maximum point here, when I say point, when I say value, maximum value, I am talking about y coordinates. When I say when it is achieved, when it is attained, I am talking about the x coordinate. When I talk about extreme or turning point, or in particular for this problem, maximum point, I mean both of them in an ordered pair, 5/6 and 1/12. Okay, so good that I remember that I have to put the computer charger, or I will face problems. Just a moment, please. Sorry. Okay. So any questions here? So one thing I want to add today is the line of symmetry. Yes. So what is the line of symmetry? If you remember the graphs that we did with GeoGebra, all of them are symmetrical. Yes. With respect to a line which is passing exactly through the turning point. So what I'm saying is that if you draw the graph of those functions, for example, completely correct, of course, you have to be precise to see the symmetry exactly, to detect it with your eyes. So here, if this is the turning point, in this case, the minimum, the line which passes through this point, and it is perpendicular to the x-axis. If I do it very precisely, in this picture, it is not clear. It's tilted a little bit toward the left in my picture, but this is completely symmetric with respect to the line, which is passing exactly through the turning point. Okay, so let me ask you, what about, do you remember we talked a little bit about this in Math 1C? We also talked later a little bit about that. No, more extensively about this. So if I give you, this is, for example, 2. If I draw a vertical line passing through that point, then this line has an equation. That equation means what is the relation between the points on this line. Okay, if you agree with me, if I make it a vertical point, a vertical line, it doesn't matter which point I am choosing on this line. There are infinitely many points, but all of them have something in common. What is that something in common? All of them have the same x coordinate, and that is equal to 2. So this means that this equation is an equation which represents this vertical line that passes through this point. Okay? For example, if I ask this question, let me clean this a little bit here. If I ask this question, I give you a point here. For example, point with coordinate x equal to 3, y coordinate equal to 2. This is the point 3 and 2. And then I ask you, I draw a vertical line that passes through this point. Okay, so this is my vertical line. If I ask you what is, so this point If I ask you what are the coordinates of this point, you would say 3 and 2. But if I ask you what is the equation of this blue one, it means that what is the common property of all points lying on this blue line? They have different y values, but all of them have the same x value. So I would write that the equation of this blue line is x equal to 3. This means that all of these lines, all of these points have that thing in common. So x equal to 3 is an equation that represents all these points on this vertical line. So I would say that x equal to 3 is an equation representing this blue vertical line. For example, I can ask you, I think it's not for us, it's not important for us, but it is possible to ask this question as well. So what do you think would be the equation of this red line? What do you think it would be? You mean that you need to think about the common property of all these points on this red line. What is the common property of all of them?
Y is equal to 2.
Yes, exactly. So this means that the equation of this red line is y equal to 2. So if you know one point, and if you know that your line is supposed to pass through that point vertically or horizontally, you can immediately answer the question what the equation of that line is. If you are interested in a vertical line passing through that point, you say x equal to the x coordinate is the equation. If you are interested in a horizontal line passing through that point, you would say y equal to the y coordinate is an equation for that line. Now, if I ask you what is this one, you agree with me by this calculation that this is the maximum point on your parabola. And so let me try. Of course, I don't know the exact picture, but what I want you to understand is that if you have a turning point, for example, if I tell you that the coordinates of this point is A and B, and if I tell you that my parabola is something like that, and if I ask you, give me the equation of the line of symmetry. What is the line of symmetry? The line of symmetry is this line, which passes through the turning point perpendicular to the x-axis. So if I ask you, what is the equation of the line of symmetry, it is clear. You write with the same analogy, x is equal to A. So it means that if you want to find the line of symmetry, what you need to do in principle, again, you need to find the turning point. But for maximum, y value is important. For a line of symmetry, x value is important. Because the symmetry line is a vertical, so it means that x coordinates are important for us. Okay, anyway, I was able to read the x coordinate. What is the x coordinate? Is x 5 equal to 6. So if I ask you what is an equation for the symmetry line, the answer would be x equal to 5 over 6. Be careful. You cannot just simply write 5 over 6. That is wrong. 5 over 6 is not an equation. An equation needs an equality sign. So you cannot say that to answer to this, if you write 5 over 6, it is wrong. So you will lose all the points. What is an equation for the symmetry line? So x equals to 5 over 6 is an equation for the symmetry line. So remember this. The symmetry line is a line that passes through that point, that turning point, perpendicular to the x-axis. Okay, so that is something we also, I want you to know about that. Of course, there is also another way to find that. Because if I find these roots, the nulle stelle in the book that you are called, so you immediately see that because this is the line of symmetry. If I ask you what is this point, you immediately realize that these two line segments have to have the same length. Yes. So it means that you need to find, if you find the roots, for example, if I tell you that this is 1, and if I say you that this is 6, if you want to find the middle point, that is also working. What is the middle point? You add them, make the average. 1 plus 6 divided by 2, it's 3.7. So, sorry, 3.5, or 7 over 2. And then you say that the equation is 7 over 2, x equal to 7 over 2. So that is also one way to do that. So might be if they ask you about the line of symmetry, you can use this trick. Find the roots, add them, and divide by 2. X equal to that is also correct. But what is the downside of it? The downside of it is that sometimes we do not have any roots, yes? Because it might happen that my parabola is like this. And it does not intersect the x-axis. Okay? So then this trick will not work because I do not have any roots. But what happened? Later, the next week, when I was teaching the complex numbers, you will see that if this happens, there are not roots in the real numbers, but there are still roots in the complex numbers. So it turns out that the same trick will still work even if you do not see them here. So it means that you find the complex numbers, the roots, the complex roots of this, and then you add them and then divide by 2. X equal to the number that you get is actually actually the line of your symmetry line. So let me just do a review. The new lesson today is to find an equation for the line of symmetry. You need to take this for granted. Of course, it needs to be proven, but this is not beyond the level of Math 2C lesson. But you need to take this for granted that, yes, this object, this parabola, is always symmetric. When I say that parabola is symmetric, you have right to ask symmetric with respect to what? Then I will tell you with respect to the vertical line that passes through the turning point. Okay? This is the ideas behind it. Then you might ask, is there any way to write an equation for the symmetry line? I would say yes. I would present two methods. The first method is actually the completing a square method. But for the completing a square method, usually you might be interested in max and mean values, but for a symmetry line, you will be interested for where it is achieved. I am interested in the x-coordinate of the turning point. And then when I have the turning point, you have to write x equal to that number. This whole package is the answer to the symmetry line, an equation for the symmetry line. An alternative way to do that, is clear in this picture. Because when this is supposed to be the line of symmetry, if these two are roots for the equation, it means that they are also symmetric with respect to this line. So if I succeed to find the middle point between these intersection points, I am done. For example, I gave you assume that this is 1 and this is 6. Immediately you can find the middle point. How? You just add these two numbers and then divide by 2. This will give you the middle number. So the middle number is on the symmetry line. So x equal to the middle number is an equation for the symmetry line. What is a little bit downside to it? The downside to it is this. You might have a parabola that does not intersect the x-axis at all. So it means that there are no null stelle, there are no real roots for that. Okay? So then what can I do? In principle, this will not work. You have to go back to this original method to find that, because still I have a symmetry line. The point is that this parabola does not intersect, but it doesn't mean that my parabola is not symmetric. It's still symmetric. But then I will tell you, when I taught you about the complex numbers, you will see that if this happens, there are no real intersection points, yes, but there will be two complex roots. If you add those two complex roots and divide by 2, the same method again will work. Okay? But for the time being, I think this is very good that you know how to complete the square. If you complete the square, you can answer all questions regarding your parabola simultaneously. You can talk about the maximum or minimum values correspondingly. You can ask when it is achieved. You can give me the coordinates of the turning point. And if I want to, you can give me the equation for the symmetry line. So this is a whole package of quadratic polynomials. If you complete the square, you can answer all these questions with one completing the square. Okay? So hopefully you understood what's going on, but I want to do it. This what I am trying to right now do here is optional. But I want to increase your level of algebra skills. I want to do the same story once for all for a generic polynomial, quadratic polynomial. Okay? To see, can I find a formula? If I can add that formula into the formula sheet, then it would be very easy, everything for you. But of course, those formulas are not in the formula sheet. But you can invent the formula yourself. So this is an optional lesson, but I want you to listen to learn, okay? So what is my point? My point is that I do not want to work with a particular quadratic equation. I want to start working with the most general form and do the same things, but algebraically. What is the benefit of that? The benefit of that, I can do it once for all and write the formula that I get in a piece of paper and use it all over again. Okay, so let us do that. But of course, it is helpful because it will teach you how to use algebra effectively. So let me start with this. And I think I have to change this pen. Just give me one moment. Okay, so this is my parabola. I want to find the coordinates of the turning point. Using that, I can answer what is the maximum, what is the minimum correspondingly. I can also answer what is the equation of the symmetry line. I want to do all of them by doing it algebraically. So you can help me. You remember, when I talk about a quadratic equation, I always assume that a is not 0, because if a is 0, then this is not quadratic in the first place. So, and this is important because now I want to divide both sides. Do you remember? We just solved a problem today. It was -3. The first thing that I did, I divide by that number. So here I divide by a. You see, it's very easy. I divide by a. This becomes x squared. This becomes b over a times x. This becomes c over a. So what I have to do, I need to find that number so that when I add this package becomes a complete square. So I go to scratch paper. You see, I am following exactly what I was doing for the previous example. So I divide b over a by 2. So what I do, I give a denominator 1 to it. I multiply these, it becomes b, put it in the numerator. Multiply these, becomes 2a, put it in the denominator. But then I have to raise it to power 2. So this becomes b squared over 4a squared. Yes? And then this is the number that I have to add. Let me just repeat. You see, it's like a time machine. I am repeating more or less everything. But I cannot bring up this from my pocket and put it here. Yes, do you remember these words from me? So I'm just repeating it. Okay, and then I put c over a here. But if I want to respect this equality, what I have to do, I need to do some compensation for that. And I have to subtract this to make it right. You see, I am doing everything as I was doing before, algebraically this time. So these 3 is a complete square. So I would write y over a is equal to, I put a power of 2 here, take the square root of this is x, take the square root of this one, it is b over 2a. And then this is the positive version, plus version, I put a plus. Then in the previous problem, do you remember, because they were numbers, what I did, I actually went to scratch paper and calculated this number, wrote it as a more compact number. But here I have to deal with letters, yes? Variables. So what can I do? I can do more or less the same thing. Let me go here to a scratch paper. So let me write it in this way. So here it is c over a. And then I have minus b squared over 4a squared. Of course, I can work with it all the time, but let me take the common denominator. The common denominator, I hope that you agree with me, is 4a squared. So I want to make it 4a squared. How? By rescaling it by 4a. If I multiply 4a in the numerator, it becomes 4ac. The denominator becomes 4a squared. It's good, because the denominators become the same. Okay, so this is something that I want to ask you. What's your opinion about that? So the denominator is, of course, 4a squared. But the numerator becomes 4ac minus b squared. Can you see something familiar to your eyes for the numerator? So the denominator, I will write 4a squared. But do you see something familiar to your eyes? What is the numerator? The numerator is 4ac. It's very similar to something.
It's similar to conjugate pattern, but I don't think.
No, not conjugate pattern. I gave it a name. Then we were solving quadratic equations.
It's the delta.
It's delta, but not 100%. It's very similar to delta. What's the difference? Do you remember what is delta? The discriminant. Discriminant.
Delta is b squared minus 4ac.
Yes. Discriminant delta is b squared minus 4ac. Okay. But now can you tell me, if delta is this one, what is this one then?
It's the negative version.
Exactly. So it is negative version. So if I multiply this by negative sign, it becomes negative delta. This becomes positive 4ac, and this becomes negative delta. And that is exactly the expression that appears there. So this is nothing. Of course, I can work with this one, but if I want to memorize, because I have already spent my energy to memorize delta, so let us use it. This becomes negative delta. So what I want to write here, I put delta here, and I put a negative delta. That's it. Okay, so let me come back here. Let me write I want to copy paste here to be on the board up here that you can see it. I'm just copy and pasting. X plus b over 2a to the power of 2 minus delta divided by 4a squared. Now, can you tell me what is this one? It is greater than or equal to something, yes? Because this one is greater than or equal to 0 because of this power 2. So can you tell me what should I write here? The whole expression is greater than or equal to what?
Negative delta over 4a.
Exactly, thank you. Okay, so let us copy and paste these two important parts down there. Y over a is equal to this, but this itself is greater than or equal to that. So it means that this is greater than or equal to minus delta divided by 4a squared. Okay, now this is the crucial point. When I was dealing with numbers, it was clear for me if this number in the denominator is positive or negative. But here I am working with a variable. A variable can, in principle, take on a negative value as well as a positive value. And then because I want to talk about y, I have to make y alone. So I have to multiply by a. But this is the crucial thing that I need to remember. I have to decide what is the sign of a. If a is positive, then I don't have any problems. I multiply both sides by a times y over a greater than or equal a times minus delta 4a squared. Because a is positive, I can keep the direction of the sign. But then this a and that a are cancelled. Y is left for me greater than or equal to a and this a are cancelled minus delta over 4a squared. 4a is left for me. But it might happen that a is negative. I can do the same calculations, multiply both sides by a, but because now you are telling me that a negative, I have to be careful. I have to flip the sign. So this becomes y is less than or equal to minus delta divided by 4a. Okay? So let me collect what I have so far. So I realized that the y that I was working, let me write the y again. I was working with this y. I realized that there are two possibilities. If a is positive, then y is greater than or equal to minus delta divided by 4a. So if I ask you, do you have a minimum or a maximum for y? You say a minimum because you say y is greater than or equal to this. So I am done. Actually, this is a rigorous mathematical proof for that claim. If a is positive, I have a minimum value for y. But if a is negative, then look back here. If a is negative, when I multiplied by a, I had to flip the sign. So then it means that y is less than or equal to minus delta divided by 4a. So you see that if a is positive, I have a minimum for y. If a is negative, I have a maximum for y. And that is exactly what I was claiming from the beginning, that please trust me on that, I can motivate it for you. So I hope that now you are motivated. But more than that, we can ask you, I can ask you when this max or mean is achieved. Okay? This max mean or mean is achieved. Okay, can you answer this question now based on your experience? Is achieved when x is equal to
divided by 2a.
Minus b divided by 2a.
Oh, minus.
Because you want to make this equal to 0, yes? Do you remember? You put this equal to 0 and find the answer. Minus b, exactly. Minus b over 2a. So now everything becomes clear for me. What is the coordinates? What are the coordinates of the turning point? The coordinates of the turning point is minus b over 2a and minus delta divided by 4a. So this is the general formula once for all. Yes? And if I ask you what is the equation of what is an equation of the line of symmetry, that is exactly the value for x. So an equation for the line of symmetry, for the symmetry line, is x equal to minus b over 2a. Okay, so this is the summary done in general. But of course, don't be happy. These are not given to you in formula sheet. But anyway, you understand what's going on. I forgot the name. I forgot the numbers in the previous example. Can you just read it for me? What was the last example I solved? I remember I start with y with negative 3x squared. I think it was 5x here, and then I forgot. Yes, can you read it to me, please?
It was negative 3x squared minus 6x plus 7.
Are you sure it was minus 6? No, just example today. This the first example. It was not minus.
Oh, example today. I thought you meant the last lesson.
No, not this lesson. This lesson, exactly the first example. Haven't you written it down? Anybody?
Minus 3x squared plus 5x minus 2.
Minus 2. And can you please read me the turning point? What was the turning point after all those calculations we reached to? Yes, Gustav, can you see that in your notes?
The turning point was the x coordinate.
What? The turning point.
Was the turning point the x coordinate?
The turning point.
Well, okay, I think it was 5 over 6.
But what is the y value? What was the maximum? What was the maximum?
And 1 over 12.
1 over 12. Thank you. So that was the maximum, and that was the x value. Okay, so you see, we calculated so long so that we reached to that particular number. But assume that you have this formula. You don't need to do anything. You just put the formulas, the numbers in the formula. But of course, it's important to understand. Otherwise, that is a childish act. Yes, I give you a formula, just put the numbers there. You need to understand what's going on. So here in this problem, a is equal to minus 3, b is equal to 5, and c is equal to minus 2. Okay, so I can calculate minus b divided by 2a. This is the x coordinate of the turning point. So minus b is 5, 2 times minus 3. So it is 5. 2 times minus 3 is minus 6, minus positive. And you see, as simple as that. This is this answer. So the calculation is half a line. But of course, we have paid the price. We have calculated it once for more. So this is the power of algebra. So assume that you want to write a code in a computer so that whenever you give it a parabola, it will give you the turning point. Okay? So if you want to teach the computer how to complete the square, it would be hard. But you can complete the square once and find the formula, and then ask the computer all the time calculates this for you. And that's the power of algebra. Okay, and then if I want to calculate this 1 over 12, I see the formula here. It's minus delta divided by 4a. But hopefully so far you have remembered what is the formula of delta. Delta is b squared minus 4ac, and then I have 4a here. So let me plug the numbers in. The minus sign is in the formula itself. B is 5 to the 2, minus 4 times a times c, divided by 4 times a. Then you calculate. 25, oh, sorry, there is a minus sign here. 25 minus 2 minus 3 is multiplied positive 6. Positive 6, this is negative 24. 4 times minus 3 is minus 12. We are done because 25 minus 24 is 1. Minus minus becomes positive. And this is your second number. Okay? So this is, I want you to understand that we didn't actually, so it tells you everything about the quadratic polynomial that you want to do. If I ask you what is the symmetry line of this, you say that the symmetry line is x equal to the number that I get for here. So that is 5 over 6. So you can see that I can answer all sorts of questions regarding this quadratic function. Okay, I want to stop here today, but I will spend half a session. I don't know, Monday is a long session. At least you will also be here. Okay, that's good. So I want to talk 1 hour at most to something which is very important to see, is there any practical application for finding a maximum and minimum? It turns out that yes, there are actually very many applications of maximizing or minimizing of functions. For example, and they are gone under the title of optimization. Optimization is a better word for that, because, for example, assume that you want to run a business. Okay, optimization for you is to maximize your profit, and on the other hand, minimize your loss. Okay, so if it comes to loss, optimization is minimizing. When it comes to profit, optimization means maximizing. So more or less, we should imagine that there would be quite big applications, tremendous, broad applications, yes, of maximizing and minimizing functions. Here in this Math 2C lesson, you only learned how to maximize and minimize a quadratic equation. But of course, in reality, there are not that many models. Of course, there are very important models following a quadratic pattern. But of course, there are many other patterns that cannot follow this pattern. So then it raises a very important question. Can we solve this maximum optimization problem for different models? The models so that they can be formulated in an equation, but that equation is no longer a quadratic equation. The answer is fortunately yes, but the trick is totally different. Okay, so this function was so simple. By just completing a square, I was able to say something about its maximum or minimum and when it occurs. But if, for example, it's a trigonometric function involved, many periodic phenomena in nature are following trigonometric equations. So then what can I do? How can I think? There is no completing a square there. So, but still, is there any way to maximize or minimize those functions? The answer is yes. And then you have to learn the notion of derivatives, which comes in Math 3C. And then if you study Math 3C, this would be a matter of seconds to find that number. Later, you will learn that if you give me this function, it takes me even 1 second to differentiate it. That's a concept that you will learn. It becomes 2ax plus b. and then you put it equal to 0, 2ax plus b equal to 0, then you find x. You move b to the right, it becomes minus b. You divide by 2a, it becomes 2a. And that is exactly the number I was suffering a little bit to determine here. Okay, so but this would be the topic of Math 3C and Math 4, and of course at the university level. What I want to tell you that don't think that this kind of trick will work to maximize and minimize all sorts of functions. That was more or less, I would say, a coincidence. So for example, you can immediately think about this problem. If I want to increase the level of this problem to a sort of problem of this kind, but a little bit higher, you might think about a third degree polynomial. But the third degree polynomial, what can I do with that? It's not clear. Here I had a second power, then I was thinking might be completing a square will work, yes? But can I do something similar for that when I go higher and higher? So these questions are not very easy questions to answer. So it means that if we want to push ourselves to extend this method, so because the first thing that comes to your mind is that, okay, I learned something about the second degree equation, so let me try to ratify, I don't know, to change, to make it fit to the next type of functions. This is the first impression that comes to mind. But it turns out that this is a failure. It will not be, we will not be able to extend this idea further in this way. So we need to sit down and start completely new way of thinking. And that would be the notion of derivatives that you will study later. Okay? I think I can say goodbye here on the stream on YouTube, and then we go to Zoom. If you have any questions, I will be there to answer your questions. Okay?
Okay.
Thank you.